Good afternoon, everyone. We're going to move on to looking at mirrors. Mirrors are very similar to lenses. The only thing that we need to remember, and it's not intuitive even though it should be, is that mirrors reflect and lenses refract. So we always expect the image to go through a lens, but we know that the image does not refract in a mirror. Otherwise, there would be no point to the mirror. Okay? So mirrors reflect, lenses refract. When we look at curved mirrors, when we look at a lens like this, and we have our lens and our focal point and then our object, we always do it in 3 steps. Through the first focal point, and then parallel from the plane of principal plane, parallel to the axis, and then through the second focal point, and then through the center of the lens. This is for a lens. When we draw an image for a mirror, we need to remember to go through the curvature of the mirror. And so what we need to do in that point is we have to figure out, so if we're looking at a mirror like this, we need to figure out halfway. And the way that we figure out the focal point is the center of the circumference. That's the word I'm looking for. Divided by 2. Okay, and that will be halfway. So if I look at this, and then halfway would be right there. So focal point is circumference divided by 2. We have 2 types of mirrors. Convex mirrors are mirrors that bow out towards the object. So if I have a plane here and I have my mirror like this, and the object is here, this is bowing out towards the object. This is convex. And if it's bowing away from the object, here's my object, this inward curvature is concave. So we learned this terminology in grade 8. Grade 8 was a really long time ago. So this is how we're going to remember it. Convex bows out, and concave caves inwards. So just like we had rules for mirrors or for lenses, now we have rules for mirrors. So in this space, we're going to do 3 sets of drawings. So we're going to look at concave mirrors first. So we're going to draw our principal axis. And I'm just going to continue it on over here just to make my life easy. And then a third one. Okay, let's focus on concave mirrors first. So remembering that a mirror is concave, it's going to bend away from. And then we also show this piece here where we draw the lines on the back side. It's just to show that this is solid backing in behind, that it's not an open space. And so if I have my object, this is my object, and I have a focal point, to figure out where my circumference part, my C, is the center of my curvature, again, I'm going to take my focal point and I can multiply it by 2. So here, if I want to find out where my center of my curvature is, I can go 2 times my focal point. Or if I wanted to find my focal point and I was given the center of curvature, I could divide it by 2. So if I took this point and I multiplied it by 2, probably my C is right there. Okay? So first things first, we're going to go parallel to the plane of axis. And then we're going to come back through the focal point. Same rule as in mirrors, or as in lenses, sorry. So we're going to do this. This is rule number 1. You're going to go parallel to the plane of axis. You're going to hit the mirror, and then you're going to come back through the focal point and out. The second one shows so if I keep my object in the same spot, my center, my focal, okay, so the second rule, I'm going to draw this one in first. I pretend that it actually hit my mirror. Go through the focal point. The second one is going to go through the focal point to the mirror and then parallel. So the first two are very much similar to lenses, because lenses you can go either through the focal point to the principal plane, so the center of the lens, and then parallel out. And then you can go, or you can go parallel to the perpendicular axis to the center of the lens, and then through the focal point. It's the same. It doesn't matter which way you do it, as long as you do these 2 steps for sure. Like this, and then we're going to go parallel 2 this way. So we did parallel 2 and through the focal point to the mirror. And we went parallel out. Okay. This one goes parallel to the principal axis to the mirror, and then through the focal point. So rule 1, parallel to the principal axis and then reflecting back through the focal point. Second rule is through the focal point and then reflecting off the mirror parallel to the principal axis. And then the third one is through the center of the curvature to the mirror. And it reflects back on itself. So it comes this way, and then it goes back this way. Well, maybe I should show you. Okay. So the third line did this. It went through the center of curvature and hit the mirror, and then it just rebounds and goes back. It stays in that plane. So this is the third rule. And we can see here then that the image that we see is right here. This is the image. Okay. What can we say about this image? It's inverted. It's smaller. And now this time, the only thing that's different is we're going to say it's real. The only way a mirror works is if you can see your reflection. If you can't see your reflection, then your image isn't real. Kind of that's how it's going to work. Now with a convex mirror, we're going to draw a mirror. And this is the solid part here of the mirror. Okay. Now the focal point is going to be behind the mirror. And again, the curvature is going to be double the distance from the focal point. Okay, first rule, we're going to go from the object, and we're going to go to the mirror, parallel to the axis, and we're still going to look at the focal point. Only this time, the focal point here is going to extend this way. It's going to reflect like this. Okay, first rule, same as a concave mirror, only we had to extend it through the focal point. The second one does the object. So we're going to repeat this. So the first step. Second step then is to go through the focal point first and then come out. So what we're going to do is we're going to line this up with the focal point. We're going to do the real image where we hit the mirror, and then we're going to go parallel to the mirror. So I'll just show you that this was in line with the focal point. And then we go parallel. Okay, so it reflects about the center of, or it reflects off the curvature, but it's imaginary through the focal point at that point. So we'll do it again here. I'll go this way. And then we're going to change our mind here. I'm going to change your mind. Aha. This is not wrong. It's just not where we want our line to be. This is what we're doing. But we're going to extend our imaginary line out differently. You're still going to do this first bit where you line up with the focal point, but when we take our line that's parallel to the axis, we're going to do our imaginary line this way. There we go. That makes way more sense. That's rule number 2. So let's just recap this because I changed it mid-drawing. You're going to go from the top of the object, line it up with the focal point behind the convex mirror, draw a solid line to the plane of the mirror, then go parallel to the axis and extend back your imaginary line behind the mirror. And then the third rule that we're going to work on is going through the curvature. So then if we line this up like this, and we go through it, this is all an imaginary line through here. What we can see is that our image convenes. I'm just going to put one more dash in here. One more dash. There we go. We can see that our object ends up here. And when we look at our original object to our image is upright. Our image is smaller. Now the thing is our image is behind the mirror. We can see that the rays are scattered. It's going this way and it's going this way, and technically it goes back this way. Right? If I was to take the yellow line and go out, it goes this way. So it's completely scattered. And when we know from grade 8, when we look at light that reflects off of a mirror that's scattered, we don't see an image. So now this is going to be virtual. Okay, so upright, smaller, and virtual. So we see that the characteristics are the same since mirrors are designed to reflect light. Real images are on the same side of the mirror, and virtual images are on the opposite side of the mirror. That's one of the only differences that we see. Let's look at some diagrams. Draw the ray diagrams for the following mirrors and use diagrams to identify the characteristics of the image produced. An object is placed anywhere between the focal length and a concave mirror. So let's draw our mirror. This is our principal axis, if you remember the terminology. And we are going to place a concave mirror. Concave mirror. And this is our, oh, put my lines on the wrong side. Wait. There we go. That makes more sense. We're going to put our object here. And it said to place the object between the focal length and the mirror. So I'm going to put our focal length here. And we need to go twice the distance. So if this is 31 millimeters, I'm going to go another 31 millimeters. Because remember, the C is 2 of the F. Right? And then I'm going to follow through the rules. So I'm going to go from the top of my object through the focal point. So through the focal point to the top of my object, like this extends out, and I'm going to go parallel to the plane. It's going to do this. I'm going to do from the mirror, from the object to the mirror, parallel to the axis, and I'm going to take it through the focal point. And I'm going to take my center one through the object, like this. And I'm going to extend my line. So rule 1, rule 2, rule 3. Rule 2 didn't really work out because it's all on its own and it's just going to keep diverging away. But we have 2 out of the 3 rules meeting right here. And so what can we say about this? We can say that it's upright, virtual, and larger. Now, when we look over here, we can see that these rays, especially the pink line and the yellow-purple lines, they just, they don't intersect. They don't converge. Okay? Another word for converge is intersect. Like this here is an intersection. They don't intersect. So therefore, we have to extend our reflected rays back. So we have to extend them as if they were going to go through the mirror. Let's look at this one. An object is placed at the focal point in front of a concave mirror. So concave mirror. And here's our focal point as well as our object. Our object is at it. So we can look at this particular way here where we go parallel to the axis. And then through the focal point. Okay. We can go, again, we know that C is equal to 2F. So if this is going to be 24 millimeters, I'm going to go another 24 this way. Here's our center. Going to take the top of my object and I'm going to go through with my mirror, and then this is extended. This is going to come back on itself. Now this little part here is a little bit misleading, this part right here, but because they're exactly double of each other, these lines will never, I'll straight out. The rays are parallel. Okay, can we do where we go through the focal point with the object? No, because that's this line right here. I'll draw it in for you, but it won't happen. Pink doesn't happen because it's right at the focal point, which means that there will be no image seen. Okay, as long as, because this is 2F, this is the equal distance, these lines should be the same all the way. They should be parallel. Okay, third question. Says, third question says that an object is placed anywhere in front of a convex mirror. Okay, going to switch it around. The notes show the diagram a little bit different, but it's the same idea. I just literally did a mirror image for which you can't see. Okay? Here's my object. My focal point is here. Remember that C is 2 of F, 23-ish. Here's C. Okay, so first rule, we're going to go from the object to the mirror. Parallel. And then we're going to go through the focal point. That's the first rule. Second rule says to go through the focal point. And then remember I did the extended dot out, but actually what we're going to do is we're going to flip it. And then it's going to reflect this way, but then we're going to go through the mirror. And then the third rule is taking the top of the object through the center of the curvature. Okay, and then extend it through the mirror. And what we see here is an image. And what can we say about this image? This image is upright. This image is smaller. And again, this image is in behind the mirror. And so it's virtual. And it's virtual because the focal point and the center of the curvature are behind the mirror. So it just goes without saying that our image is also going to be virtual. Because here we have the object inside of the focal point. Here we have the object at the focal point. And in here we have the object in front of the focal point, except that the focal point is behind the mirror. If the focal point was here, we would have an image on this side. So I want you to go through these questions here. Again, don't do the dimensions chart, and make sure you really understand how to draw these diagrams out. Make sure you have a solidified understanding of a converging lens, a diverging lens, a convex mirror, and a concave mirror. So this is converging, this is diverging, this is convex, and this is concave. These are lenses, these are mirrors. Okay?